Chapter 1B Review. Be prepared and study for these questions, and you will be ready for the chapter test. So first section, you are asked to give the domain and range for each. Take a look at example number 1A. You are given a graph, and what does the graph look like? We have been practicing this for the last few days about transformations, so I'm assuming you know it's a quadratic equation. It looks like an opening up parabola. That's a quadratic. So what's going to be my domain and range? When we had this discussion, I repeatedly tell you that the domain is going to be your input. So it could be either called the domain, the input, the independent variables, or just the input. So what's going to be our input? So most of the time we put our input as the x-axis. So we have x can be any real numbers. Remember, this is drawn to you on a real number line in the graph. Real number line. So your x can be any real number. So notice that this symbol, like the inverse e, it's read as the belongs to. The inverse e read as the belongs to. How about our y? So the graph has a minimum value. I put a red dot right on the vertex. It has a minimum value of 1. So y, the output, or the range, or the dependent variables will have a value greater or equal than 1. Y is going to be above 1. Letter B, you are given 5 pairs of values. So how do you define the domain and range? These are given to you as discrete values, not like the graph in letter A. So all you have to do is list the number given. And remember, the first number is always your x, which is our input. The second number is always your y, which is the range. So for domain, I'm simply writing out 8, 10, 16, 20. If there's duplicates, you don't really have to duplicate them twice. How about the range? Range again is always the second number from the given pair. 4, 10, 11, and 100. Remember, this is the case given to you in discrete values, not like the graph A. Graph A is a continuous case. Letter C. So again, you're given specific 4 points. So letter B and letter C, I would say they look closer together. So what would be the domain? What would be the input? So identifying your x values on these points. So we have -2, 1, 2, 3. That's the input. How about the range, the output? We have 4, 3, 1, -3. So be sure to tell the difference between letter BC to letter A. BC are given. Question number 2. Determine whether each is a function or not. Justify your answers. So for letter A, it passes vertical line test. So every input has its own output. So this is definitely a function. Letter B, I circle. If you notice that I circle the 2, there's one input, but it has multiple. It has more than one output. So I'm going to emphasize again. If one input has more than one, I didn't say 2 output. If it's more than 1, then it will fail the vertical line test. Letter C, so for each individual input, it has its own output. So this is definitely a function. Letter D, this is a sinusoidal wave. If you continue pursue higher level math studies, we will discuss this in pre-calculus. A sinusoidal wave is definitely a function. It will pass the vertical line test. Even though it looks like it's repeating continuously, it will pass the vertical line test. So as long as one input has exactly one output, this is a function. Question number 3. Find f of -3, f of -1, and f of 2 for each. So letter A, it's a given graph. I marked on my graph. You're looking for -3 on the x-axis. So draw a line and then see where it intersects with the graph. And then find your y values. So when x equal to -3, as you extend that line, you'll see that the graph is intersecting the y at -3. F of -1, So again, draw the line. It's going to intersect the graph with y value of -1. When f of 2, x equal to 2, it's going to intersect the y at 1. Letter B. So for this type of given functions, you simply directly plug in the values. When x equal to -3, -3 squared minus 2 times -3. So when you have the negative value, make sure you put a parenthesis. So the final result should be 15. f of -1, again plug it in with negative value, put a parenthesis over it. The final value is going to be 3. f of 2, so 2 squared minus 2 times 2, which is 4 minus 4 equals 0. Question number 4. Transform the following functions. So you're using the given functions to the left-hand side as the parent functions, and then follow the instructions to transform it from down 4 units as letter A. So basically I separate, remember I said when we talk about the piecewise functions, put a line to find the distinguish between linear equation to the quadratic equation. So that separating line is going to be located at x equal to -3. And then for the left hand, to the numbers less than -3, it's a linear equation. So I transform down 4 units. Same thing with the quadratic. And the most characteristic part for the quadratic is the vertex, which is located at -1, 0. So using that point, I move everything down by 4 units. So the final result is going to be shown in your letter A, red color. Letter B, reflect across the y-axis. So as we mentioned, when you are reflecting across the y-axis, so imagine you are putting a mirror on the y-axis. Taking the linear equations, so it has a point located at -3, 4. It's going to be reflected, since it's reflecting across the y-axis, it's 3 units away. So now I would have a point located at 3, 4. And then it has a slope of -1, it's still going to have the same slope of -1 going down. So you can check your answers with the graph in B. Number 5, describe the transformation for each. The darker colored graph has been transformed from the lighter parent functions as shown. So letter A, transformations. So I try to show you that the question number 6. Give the parent function, transformation, and graph the functions. So letter A, x is inside the square root symbol. So it's going to be, the parent function is going to be square root functions. And there's nothing with the h and k. Only the whole function is being multiplied by 2. So we know there's going to be a vertical stretch factor by 2. Letter B. Again, we see this square root, the radical expressions over the x, the square root symbol over the x. So the parent function is going to be the square root. X minus, so 4 is inside working with the x. So we know there's going to be a horizontal shift right 4 units. 4 is a positive number. X minus, so make sure you keep that. X minus, it's part of the information you need. Right 4 units. And then plus 1 is outside of the radical expressions, so it's going to tell you move the whole function up by 1 unit. Letter C. Variable x is being raised to second power, so that's the quadratic. The whole function, quadratic is being multiplied, so the x squared is being multiplied by negative. So when it is negative, we know it's going to be reflected across the x-axis. Letter D. The absolute value functions, you see the 2 bars across the x-axis, the x value. So that's going to tell us it's the absolute value functions. So it's going to move left 2. So don't forget to make it into x minus -2. X minus -2. -3 is outside, so again it's moving the whole function down by 3 units. How do you graph it? Don't forget to graph your functions. So for this one, I'm going to use multiply by 2, so you know it is experiencing a vertical stretch by 2. So 0, 0, right 1 up 2, right 4 up 4. Connect the dots to make the graph. right 4 up 1. So I'm going to relocate my first starting point. Right 4 up 1, right 4 up 1. Starting from this point, I count the points. Right 1 up 1, right 4 up 2. So it's kind of like out of our graph here. Letter C, reflected. So don't forget your x-axis now serve as the mirror. Up 2 units. So I could move up 2 units first. And then from here I do my count. Right 1, down 1, right 2, down 4, left 1, down 1, left 2, down 4 to make my graph. Letter D, left 2, down 3. So I'm going to locate my vertex point first, and then since with the absolute value function, it's like a linear equation, so I know I need is just another point. So right 1 up 1, left 1 up 1. Question number 7. Simplify each expression, leaving no negative exponent. So I'm going to emphasize again, your answer should not have any negative exponent. Letter A, 2x squared over x y to the 0 power. Any number raised to 0 power is going to be 1, so we can quickly reduce it down to x squared over x, which is x. So the final answer should be 2x for letter A. Letter B, 5 over 10, so immediately you can reduce 5 over 10 down to 1 over 2. X to the 4th power, x to the negative 2 power, so 4 is greater than negative 2. So I take the bigger number, which is 4, minus the smaller number, negative 2. 4 minus negative 2. 4 was at bottom originally, so I keep it at the bottom. Y to the 6th power over y to the negative 2. Again, 6 is greater than negative 2, so I take the bigger number, 6, minus the negative 2. And 6 was originally at top, so I keep it at top. So the final answer for letter B is going to be y to the 8th power over 2x to the 6th power. Letter C, x to the negative 2 power, y to the 3rd power, raised to negative 2 power. So this time I'm using the power of a power properties. Distribute the exponents, multiply it together. Negative 2 times negative 2, that's positive 4. So x to the positive 4 power. Y to the 3rd power, then raised to another negative 2 power. So that's going to be 3 times negative 2, which is negative 6. I have to make that into positive exponent, so I have to move it down to the denominators. Letter D, x to the 3rd power, y to the 5th power, raised to a negative 2 power. So first thing, I take care of the negative by flipping everything down to denominators. 1 over x to the 3rd power, y to the 5th power. Then I distribute the 2 to both of the variables. So 3 times 2, that makes x raised to the 6th power. 5 times 2, that makes y raised to the 10th power. Letter E, this one I like to simplify the content inside the parentheses first. So m to the 4th power divided by m to the negative 3 power. So 4 is greater than negative 3. 4 minus negative 3, that makes m to the 7th power. Divide by 3, n to the 5th power. Followed by 2nd power. So now 7 times 2, I have 14. m raised to the 14th power. 3 raised to the 2nd power. So that's the part most students forget. 3 raised to the 2nd power is 9. N, 5 times 2, that's 10 power. So the final answer should be m to the 14th power divided by 9, n raised to the 10th power. Question number 8, simplify. So keep in mind when we talk about simplification on radical expressions, you are trying to take out the square root inside the radical expressions. If you have the square root expressions at the denominators, then make sure you multiply it the same thing to get rid of the radical expressions. So simplify is not asking you to use your calculator to give me the decimal numbers of any radical expressions. So again, keep in mind, you are taking out the greatest square numbers inside the square root. So take a look at letter A. Square root of 5 times square root of 50. So for 50, I can break it down to 25 times 2. So reduces the answer down to 5 times square root of 10. How do I get the square root of 10? That's 5 times 2. Letter B, 5 times square root of 20 minus 7 square root of 5. So 20 can be factored into 4 times 5. 4 is a perfect square. So I can take that out. 5 times 2, that's 10. So 10 minus 7. Only when you have the same radical expression, square root of 5, square root of 5, then you can add or subtract the coefficient. 10 minus 7, so that's 3, square root of 5. Letter C, I have to write it down below. So immediately, square root of 24 divided by square root of 2, I can reduce that down to square root of 12. So I don't have anything at the denominators. So that's a good thing. Now, square root of 12, I can factor into square root of 4 times square root of 3. Square root of 4 equals to 2. So 5 times 2, that's 10. So the whole answer reduces down to 10 square root of 3. Letter D, there's a radical expressions, which I don't like. So the easiest way for me to do this problem would to be multiply top and bottom with the